So in the previous video, we focused on what active immunity was, which is the ability to fight off the infection or resist the infection. But the thing is, your body has to do the work. So let's look at passive immunity for a bit. You see, in passive immunity, what happens here is the pathogen enters the body, but immediately after the pathogen enters the body, I just want you to see that the B lymphocyte is not active yet, and they are quite far away. So the B lymphocyte is sleeping. It's not actually sleeping, but it's inactive. So what I'm trying to represent here is the B lymphocytes have not met the pathogen. So has immune response happened? No, it has not. But the weird thing is, inside our body, the antibodies are already present. So how is that even possible? And the pathogen is quite surprised because, wait, the B lymphocytes have not responded, because when the B lymphocytes respond, they're supposed to undergo clonal selection and clonal expansion to produce the plasma cells and memory cells. And once the plasma cells are produced, that's when the antibodies will be released. But in this case, there were no plasma cells inside the body. However, antibodies were already present. So that is kind of weird. So the question is, where did the antibodies come from? Right? So, because it could not have come from the B lymphocyte, because as I've told you, the B lymphocyte is inactive. It did not respond to the pathogen. Therefore, there were no immune response. And it's also not due to memory cells inside the body, because if it were due to memory cells, the memory cells would have had to attach to their antigens through clonal selection. So this is quite weird because your body did not have to do anything, yet antibodies were already there. Once the antibodies bind to the antigens, the phagocytes can ingest it, and when the phagocytes ingest it, the pathogen is immediately eradicated. So did the person fall sick in this case? No, the person did not fall sick. Our body was able to respond immediately to the pathogen. But again comes the question, where did the antibodies actually come from? Because that's quite a big mystery, right? As we can see here, the B lymphocyte is just minding its own business. So of course, students might be like, oh, this immunity is really amazing. Because why is this immunity amazing? The antibodies are immediately eradicating the pathogen. But there are some limitations, but let's look at it anyway. So for passive immunity, the first type of passive immunity we are looking at is natural passive immunity. So what exactly is natural passive immunity anyway? So let's start with the baby. For example, like a newborn, the baby is just born, and in their body, they do have B lymphocytes. I'm going to use the word B cell because, I don't have enough space to write B lymphocyte over there. But when I say the word B cell, what I just mean is B lymphocytes, all right? And the B cells are inactive. They are not exposed to any antigens at all. So, but here's the thing. I told you before that in passive immunity, the baby's body does not have to do the work, right? The immunity happens automatically. But how exactly does it happen automatically is the mother breastfeeds the baby. And in the mother's breast milk, the mother will actually provide antibodies to the baby's body. So you see, did the baby actually produce the antibodies? No, the baby did not produce the antibodies, but the antibodies are already present inside the baby. That's why it's called passive, because I told you in passive, your body did not have to do the work. So if you were breastfed, what will actually happen is your body will now have antibodies. But did you produce them? No. It was produced by your mother and passed to you. And your B cells are still sleeping. They are just like, yeah, I don't know what is going on here. The B cells are just inactive in this situation. So if a pathogen entered the baby's body and the pathogen wanted to cause an infection, the pathogen will not have a chance to do so, because the antibodies from the mother will immediately bind to the antigens and it will immediately eradicate the pathogen. This is called immediate protection. So did the baby fall sick in this case? Chances are the baby will not fall sick. All right? So you might be thinking, oh wow, this type of immunity is amazing because the protection is immediate. I don't have to do anything about it. Someone else provides the antibodies to me. If you're a lazy person, you're like, oh, this passive immunity sounds good. However, there is an important condition to passive immunity. The important condition here is as follows. Imagine now the baby grows up and the child, we don't call it a baby anymore, the toddler is now 2 years old. And let's say the mother has stopped breastfeeding the child, right? Here's the weird thing. There won't be any more antibodies inside the body because the mother's antibodies will only last for the short period of time. So the moment the mother stops breastfeeding the baby or the child, the antibodies are no longer there. So while there was an infection that happened the first time, as I'm circling here in red, there were no memory cells produced. Why were there no memory cells produced? Because the baby's own B cells did not respond to the pathogen. A very important thing I like to remind you is when the mother breastfeeds the child, it is only antibodies that are provided to the child. The mother's memory B lymphocytes will not enter the child at all. That's an important condition to follow. So, if the toddler who is now 2 years old gets infected by the same type of pathogen 2 years later, will they fall sick? Yes, they will fall sick. Okay, because remember, it takes some time for the B cells to respond to the pathogen. And due to the absence of memory cells, the child will fall sick. Okay, and it takes a few days for active immunity to then kick in. So natural passive immunity is just acquiring antibodies from the mother through breastfeeding or the placenta. The placenta is just a structure that when the mother is pregnant, okay, the fetus will have this particular structure. The fetus is the offspring growing inside the mother's womb, and the placenta attaches to the mother. And through the mother's blood, it will share some of the substances to the fetus. And when we were developing in our mother's womb, we would also receive antibodies through the placenta. So for the exam, you must know that natural passive immunity is acquired through two processes. One through breastfeeding, okay, or number two, through the placenta. That's all we have to know. But were you the one who was producing the antibodies? No. The antibodies were produced by the mother and it was passed to the child. So the child did not have to do any work in this case. Hence why it's called passive. And because the mother is breastfeeding or it happens through the placenta, this is referred to as natural passive immunity. That's it. But the problem with natural passive immunity is the protection is immediate. That is good, but the problem is it is short-lived. So it only protects the person as long as the antibodies are constantly provided. But the moment the antibodies stop being provided, there will be no memory cells at all, right? So the person will actually fall sick in the future. So this is called a short-term or short-lived protection. Now, another type of passive immunity is known as artificial passive immunity. So let's just give a situation over here. Let's call this person L. And person L was infected by pathogens. Person L can be an adult or a child, doesn't matter in this case. So when they were infected by the pathogen grows inside the body. Remember, if the pathogen is infecting your body for the first time, usually the immune response towards the pathogen is quite slow, right? Because you do not have that many B cells. We talked about this in the previous video. So usually what happens in between the immune response time, you fall sick. It does happen and you develop symptoms. Now, under normal circumstances, the B lymphocytes will eventually respond to the pathogen. We know this. But in some cases, it's not always perfect. Maybe person L is extremely sick. Maybe they did not have enough nutrients. There can be many reasons why these things happen, but the immune system is not responding well. They are malnourished, age factors, the immune system is weakened perhaps due to immunocompromise, like due to conditions such as AIDS or sometimes even leukemia, by the way. So their immune system, their B lymphocytes, was supposed to respond after a few days, but the B lymphocytes are not responding towards the pathogens. So in this case over here, if it's not responding, um, if we were to give it a few more days, the person might die, okay, because the pathogens might spread throughout the body and just cause so much damage in the organs that the person may not be able to recover and they might die from this infection. Waiting for the immune system to respond is not a good idea in this case. Under normal circumstances, if the person was generally fine, we could wait for the immune system to kick in and respond to the pathogen, like for example in active immunity. But in this case, waiting for the active immunity to kick in might be deadly for person L. So in this case, what we have to do is we have to provide person L with antibodies. Then you might be thinking, where do we get the antibodies from? Without going into the detail of this, let's look at person M. Person M is a particular individual who has immunity against the pathogen. And because they have immunity against the pathogen, they can produce antibodies. So, which means to say, if the pathogen were to infect person M, they will not fall sick because they can immediately release antibodies and eradicate the pathogen. What we can do is we can actually take antibodies from person M, and those antibodies are then injected into person L. So this is like, for example, like blood transfusion. When you can donate blood, you can also donate antibodies from one person to another. It's called immunoglobulin therapy, but you don't need to memorize that. So here's the thing. So person L receives antibodies. Did person L produce their own antibodies? No. The antibodies were given to them through someone else. Okay? The antibodies from someone else were provided to them. And when those antibodies which were obtained from someone else were given, what will actually happen is these antibodies will immediately bind to the pathogen and it will get eradicated. But look at person L's immune cells, the B cells. Did they respond to the pathogen? No, they are still sleeping or inactive. So even though the infection happened, there were no memory cells produced because the person's own B cells did not respond. I use the word the baby's own B cells over there, but just put it as the person's own B cells did not respond in that case. So in this situation over here, artificial active immunity is acquiring antibodies from another person. And let's say 2 months later, person L gets infected by the pathogens. Again, will person L fall sick? Yes, they will fall sick because they do not have memory cells. Because their own immune cells did not respond to the pathogen, so they might fall sick in the future. So the protection is short-lived or short-term because it only protected the person at that point of time. It does not protect the person in the future. So passive immunity is pretty fantastic because the protection is immediate. The antibodies are like given almost instantaneously. But the only issue here is there were no memory cells that were produced at the end of it. So because you did not produce memory cells, if the same type of pathogen infects you in the future, you will fall sick again. That is the problem with passive immunity. So coming back to natural passive immunity, the mother provides antibodies to the child through the breast milk or placenta, and the baby, for example, the newborn baby or the toddler, will have antibodies in their body. Look at the antibodies. It's already present, as I've highlighted over there. So if the pathogen tries to enter the body, the pathogens are immediately eradicated because those antibodies can bind to the antigens and, that basically happens. But let's say 1 year later, if that child is infected, look at 1 year later, the child was no longer breastfed. So will they have antibodies in their body? No, they will not have any more antibodies. Are they protected against the same type of pathogen? No, they are not, technically. So if the pathogen enters the body, in the future, they will fall sick. They will have to fall sick. Their own B cells will have to respond, undergo clonal selection, clonal expansion, produce the plasma cells. That's going to take time, basically. And in artificial passive immunity, let's say the person falls sick due to the pathogen, they go to the hospital and antibodies are infused or injected into their body. So the antibodies are provided immediately. The antibodies will immediately bind to the antigen and eradicate the pathogens. So the point here is, as I've highlighted in pink, mother provides antibodies and antibodies are infused. So the antibodies are obtained from an external source, natural being your mom, artificial being the donor, or a person who donates the antibodies to you. The important thing to understand here is, through passive immunity, the protection is immediate. But did your own body undergo the immune response? No. As I've highlighted your B cells there, your B cells are still sleeping. They did not know what the hell was going on at all. So because your B cells did not undergo the immune response, you did not produce memory cells. So this protection that happened earlier was short term. And it only happens as long as you're given antibodies. But in the future, if you no longer have antibodies that are provided to you, you will fall sick if you get infected by the same type of pathogen. So some students are still going to be like, I still don't kind of understand this. Okay, let's look at another situation. Now the situation over here, don't need to memorize this situation by the way, but this person is very sick due to an infection. So in their body, there are too much pathogens causing harm. Now, if you are the doctor in that situation, you have two choices for the patient. Choice number one, you wait for their own lymphocytes to respond through clonal selection. Or choice number two, you inject the person with antibodies, right? But choice number one has its own problems. The problem is, if you're going to wait for the person's immune system or the lymphocytes to respond, it will take a few days. And in that time, the person might die. So it really depends on the condition of the person. If the person is extremely sick and organs are starting to fail, choice number one may not be a good choice. But the advantage of choice number one is, if the body does undergo the immune response, clonal selection will be succeeded by clonal expansion, and it will produce plasma cells and memory cells. And because of plasma cells, the person will release their own antibodies, and because of memory cells, it will provide long-term protection. So the memory cells produced to provide long-term protection in the future. And choice number one is referred to as something called natural active immunity. But let's say the doctor decides not to wait, and let's say the doctor decides to inject the person with antibodies instead, because maybe the person had one foot in the grave already. The doctor was thinking, if we followed choice number one, the person might not actually recover, the person might actually die. So by switching to choice number two, the doctor decided to inject the person with antibodies, and the antibodies will immediately bind to the antigens of the pathogen, and the phagocytes will ingest it. We talked about this in the previous videos. So the advantage here is the protection is immediate. So the patient recovers from the infection, and it quickly destroys the pathogen. The disadvantage is the person's own immune cells did not undergo the immune response. So were memory cells produced? No. So they can get reinfected in the future. For choice number one, the advantage is, if the person gets reinfected in the future, they will not fall sick. But for the choice number two, they might fall sick in the future again. And this type of immunity is referred to as artificial passive immunity. Passive because the antibodies are given to the person, artificial because it was injected, not from the mother to the child. Now, another very important thing I would like to remind students is that some students, when I ask the question, I show you the situation again. This person is very sick due to an infection, right? They already have pathogens in their body. The pathogens are causing harm. Some students will immediately say, why can't I give vaccines to this person? You do not give vaccines to a sick person. Oh my God, please do not do that. That is the equivalent of a person coming to the clinic or the hospital and they are already bleeding, like, they're bleeding due to an injury. And the doctor pokes them even more or just basically stabs them and makes them bleed even more. They're like, oh, you're bleeding a little bit? Look, let me make you bleed a little bit more. No, you don't do things like that. You do not give vaccines to sick people. Okay, that's making it worse. Because what are vaccines? Vaccines contain dead pathogens and antigens only. So if you vaccinate the person who is already sick, you are adding more foreign substances into the person's body, and you might actually just kill the person. Okay, in that case, you do not give vaccines to sick people. Please, 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 please remember that. Okay, it's quite a common mistake that students make, by the way. So do not do that at all. So in a healthy person, for example, okay, let's say this person is healthy, but there's a pandemic going on, okay. They want to be protected from the pathogen. So as you can see, the pathogen over there, it's infecting many people, and those people are running away from the pathogen. So this person over here is healthy. They have not gotten sick yet, but they want to be protected from that particular pathogen. In that case, what you can do is you can inject the person with vaccines. So the vaccine which contains the dead pathogen or the antigens will bind, it will enter the person's body, but will it cause the infection? Will it make the person sick? No, it won't, because the vaccines are just dead pathogens or antigens, unable to cause the infection. So those antigens will then eventually meet up with the specific B lymphocytes, okay? And as you can see there, clonal selection is taking place. Clonal selection will then be followed by clonal expansion. The person produces plasma cells and memory cells, and because of memory cells, the person will now have long-term protection. So that same person, let's say they're walking around in public and the pathogen tries to infect them. Will it cause them to fall sick? No, because the vaccines have now protected them, and because of the memory B cells, they can respond immediately to the pathogen and they will not fall sick. This is an example of artificial active immunity. Active immunity because you yourself produced the memory cells and the antibodies. Artificial because we deliberately put the antigens and the pathogens into your body. We wanted the pathogens and antigens to go into your body so that it tells your immune cells to produce the necessary memory B lymphocytes. So these are the differences between active and passive immunity that you must know. Active immunity has its own advantages. Passive immunity has its own advantages. It depends on the situation.